Alright, low impact development design objective of the introduction. Agencies face the responsibility of managing, protecting natural resources with other large parcels of land reserved for many of the different functions due the intensive that can be pro variety of stormwater challenges. For example, the industrial facility supermarket may generate stormwater pollutants, altered downstream hydrology. No single management practice can be universally applied to all drainage area. Figure 3.1 illustrates the removal effectiveness of the best management practices for a variety of pollutants. The table below illustrates complexity stormwater management. There are no single best practice management techniques that can be used effectively to address all of the potential watershed issues. Shows particle size grading, treatment, measurement, plant hydrologic cleaning, grosso solids. Less than 5,000, coarse to medium, 125 to 5,000 fine particles, wide, very fine colloidal particles, dissolved particles. Regulatory natural resource for the design issue for the ban regulatory compliance with the flood controls peak rate design schemes for the construction design that achieve only one objective for the pre-development control of the 2-year 24-hour storm event. The regulations often fail to consider the overall natural resources management, hydrological objectives, stewardship, responsibility, facility, budget constraints, the often limited construction, the finding of the necessary conveniency of the flood control requirements, limited framework may create a situation where regulatory requirements are met with the design result of the degradation, natural resources, low impact development principles, hydrology, introduction framework, frame design, protect overall ecology of the watershed, low impact development allows facilities to meet the regulatory requirements for. Okay. Alright, Mama. Flood control and storming infiltration, sufficient volume with sufficient filtering, targeted pollutants, and natural man-made system. Fundamental site concepts of the goal. Low impact development site planning is to allow the full development functional intent of the site activity, maintaining the site essential to natural existing hydrological function. Low impact development site design process is sequential, irritative, and embraces the following 5 concepts. Hydrology with an integrating framework of the design, distribution control with the micromanagement, stormwater control with the source, utilize non-structural sources when possible, creating multifunctional landscape building infrastructure, hydrology integration framework of the design, low impact development design, have goal of mimicking a natural site drainage process with the function techniques are used to modify hydraulic process such that infiltration for storage and to meet specific water quality, water quantity, natural resource for the directive of the low impact development design creates an effective drainage process for the stormwater on site. Stormwater management system will consist of close to the mimicking natural flow patterns when storage infiltration components are across the site. Distribution for the control of the micromanagement in order to emulate natural process for the impervious of the view of the site with a series of interconnected small-scale design control. So structural creates the opportunity for the redundancy and treatment for the control of the development. The treatment train for water quality control with the opportunity to strategically locate low impact development. Stormwater control that the source of the controlling and treating of the runoff of the bearing generated reduce eliminates the risk associated with the transportation pollutant further downstream through pipes and channel. The management of stormwater area of the source is especially valuable. The remediation required also in the case of the accidental spill and pollutants, if the problem can be easily isolated or the treatment can be adjusted. Incorporate non-structural system. Low impact development recognize the potential for the natural system to intercept the filter pollutants for the phytoremediation techniques take with advantage of biological chemical product of the plant soil complex have shown tremendous potential stormwater management. These natural systems are easy to design, construction, maintain, even though the natural occurring filtering treatment process must be quite complex. The multi-dimensional benefit using the small-scale simplified system is the soil amendment landscape, the revegetation curve, the reducing the need for the cost of largely scale construction projects of the underground concrete vaults and priority filters. Figure 3.2 illustrates a range of biological chemical products that have been documented in the curve of the bioretention cells landscape. Our construction of specialized soil plants that effectively absorb the treatment of urban runoff. Our shows the denitrification, the runoff, the biological fluoridation, rainfall, precipitates, particles, air, plant materials, evapotranspiration, absorption, nitrous trihydro, ammoniumnication, mulch, nitrogen fixation, sand soil medium, nitrification, denitrification, infiltration, drain and recharge. Utilize multifunctional landscape building infrastructures. These are a wide variety of the low-impact development practice available. The proprietary criteria select the low-impact development practice for the design of the competent contribution to satisfy with the design regulatory objective of the design feature of the multi-function satisfy with multi-objective of these development of vegetated roofs. For example, the vegetated roof can reduce the atmosphere, but the atmospheric pollution, reduce runoff, the frequency, reduce energy costs, create effective environment, attractive environment, have reduced replacement, maintenance with longer life cycle costs. There are many types of vegetated roofs that can be developed and include the pre-made grids and cells or whole systems. Low-impact development with the design strategy. The low-impact development design is an iterative process through understanding of the management objective, the details, understanding of the physical and natural resource of the site, concept of the site design that can be refined, and achieve the goal of the hydrological functional landscape long-time maintenance plan. Low-impact development site planning component of the section presented the aims of low-impact development site planning and lights existing in the site development requirements will be described. Low-impact development site design can be approached by managing runoff. Hydrological and hydraulic objective of the purpose of low-impact development site planning is to significantly maintain pre-development runoff volume, flow rate ideal, and while site conditions allow that would achieve the rate of replicate the site's pre-development hydrological functions since they are characterized as pre-development and that poor soil substantial vegetation ground covered ungraded graded topographically natural resource performs several important hydraulic functions. Facilitate infiltration, evapotranspiration, retention, detention of runoff, limit runoff flow rates, cover the ground surface, the roughness, help ground control water quality through the subsurface of filtering of pollutants and sediments. On development site, these hydraulic functions continue to provide with the preservation of the natural features of the construction, a variety of man-made features taken together. Utilization of the feature compromises distributed source control strategy designed not only to meet the regulatory requirements but also to provide supernatural resource protection, maintain areas with a high soil porosity, vegetation, ground cover, shallow pounding, will help meet these following objectives: flood control, facilitate infiltration runoff, decreasing overland flow rates, reducing risk of flood, of receiving the waters to meet the design objectives. Regulatory requirements complete. Supplementary controls may be set with the required volume control. Overall volume runoff that leaves the site kept as close as possible to the pre-development peak control. The peak runoff rate does not increase above pre-development levels. The entire runoff hydrograph that emulates the pre-development hydrograph. Filtering and treatment pollutants runoff that's directed across the vegetated areas through porous media to provide significant reductions in concentration, sediment, and pollutants in water. Groundwater recharging infiltration expedited and enhanced the groundwater recharge rate that has sustainable basin flows in the nearby streams. Low impact development design approach. Low impact development approach to site design seeks to maintain and restore hydrological input. Impacts to site development using the combination runoff management strategy, design techniques, distributed source control, integrated management practices. Low impact design requirements, site plans address the overall natural resource compliance issue of the watershed. Long-term successful approach requires an understanding the maintenance requirements of life cycle effectiveness of the low-impact development practice of the development and appropriate maintenance and pollution prevention plan for the facility. While the influence of each component of the design practice varies with the site, the general process that has been developed to ensure that all the components are considered, although preference for the low-impact development design to reduce the hydrological site on the site with the retained natural effect of the hydrological features is recognized. Significant impacts may occur, but the nature of the certain activities when compensating features are required. Low-impact development emphasizes use integrated site features that will control runoff as close as possible to the shore rather than transport pollutants attempting to mitigate loss functions. Elsewhere, Table 3.3 illustrates the general flow of the design process. 1. Conserve natural areas. 2. Minimize the development impact. 3. Maintain watershed timing. 4. Provide integrated management practices. 5. Manage pollutant prevention. This approach of the iterative process requires several attempts spans with all the design components of the most economical, environmental, effective way to describe all below individual design concepts. Alright, conservation natural areas, low impact development, stormwater management strategy to address the overall regulatory resource protection goals of the site and in watershed contact with the recovery development typically occur with the incremental. With this approach will allow with the adjustment and modification of site with the design strategy for the techniques for like dynamic resource protection regulatory issue the communities and the base often have the extensive watershed management, natural resource conservation goals, management plans identified sensitive environmental areas, preservation areas such as wetlands, mature woods, habitat. Low impact development site design should address any of the potential impacts of those areas and encourage conservation of the areas within the site. With example of the conservation include preserving the forest corridor that connects with an existing stream valley, maintaining flow of the volume discharge rates for the offsite wetlands, incorporate buffers around sensitive habitat areas. Minimize the development impacts while the portion of site selected for the placement of the road, buildings, or other development activities minimal. Disturbance techniques, site fingerprinting can be avoided without soil compaction, retaining mature trees, limiting the environmental impact of staging areas. Example, the minimal disturbances techniques include delineating, flagging small site disturbance for the areas possible, minimizing size construction impacts off-site, easement and property acquisition, minimize sites and material storage areas during and after construction, maintain flow pattern. Alright, control of watershed timing runoff patterns. Maintaining the site with the natural runoff control, restricting building over the site more previous soil will help keep the infiltration capacity of the site close to the pre-development lanes. Maintain watershed time in the site is also important to the cumulative effects. Design of the post-development watershed time concentration several sites with a significant impact downstream habitat and desirable to maintain natural vegetation. Steeply slope area retaining natural drainage. This will encourage the dispersed flow paths, consequently help the ability to reduce the development of channel to leave the erosion floating problems. Adequate drainage of the building walkway roads must provide with the tradition design off the grid with the drainage system and the effect with the increase of the rate of the runoff moves into receive with the water during storm events in terms of the produce of the higher volume of the runoff, the higher peak rate flow. An earlier runoff event would occur with unless the development conditions, the opportunity of the groundwater recharge is eliminated. Because of the infiltration into the swales, grass areas cannot be effectively occur with the runoff that passes through quickly. Overall grading objective for the low impact development is provided surface landform that will distribute it flows to shallow, slow moving pattern toward areas where the infiltration capacity is highest. Sample of low impact development techniques, control rates of runoff and water shedding timings include use of flattering rather than step or grades, provided that adequate drainage of the buildings and traffic is maintained. Reduce the height slopes to prevent runoff of the gain speed as it moves downhill, where the flow begins to accumulate, increase the length of the flow paths, and diverting and redirecting flow, preferably vegetated areas. Minimize use of the curb gutter system, pipe drain system in favor of the grass swells. Minimize the amount of the impervious area with use of the pavement. Disconnect impervious area with the direct runoff of the building's pavement onto the lawns of their vegetated areas. Keep flow of the velocity at a level and will cause erosion. Preserve natural vegetated areas existing topographically in place with the help slow runoff and encourage infiltration. Use weir and check dams and swales. Use integrated management practice. Once all the design strategies techniques have been implemented, integrated management practices select to achieve the site water quality and content objective for the integrated management practice for the distributed multifunctional small scale control selected based for the objective to achieve the site design water quality and the objective for the cost effective of the integrated management practices are not a one-size-fits-all approach. So, for example, the use of the amended soil filter store runoff may appropriate with rural road section high traffic inappropriate next to a parking area. There be subject to compaction, overall parking, and vehicle movement. Alright, pollution prevention. The goal of pollution prevention is reduce, reuse, the recycle variety of pollutants before they become an environmental problem. The final step of the low impact development design approach is to incorporate programs that keep pollution out of the runoff in the first place. Consequently, to increase the longevity of the integrated management practice, reduction of fertilizer, pesticides, herbicides, due to the implementation of the regular street sweeping or some common pollution prevention activities. 3.5 Design guidance standards. Method of determining effectiveness. Stormwater project for the typical design, particular object with the mind, with the such with the light control, water quality improvement. Some of the such projects typically require the design and evaluate effectiveness of proposed treatment at meet stated objective for the number of the hydrological models that have been developed. The model surface runoff of the drainage, give the drainage areas. Because the conventional models are primarily concerned with the computing flow rates for the flow hydrograph, the point interest with the approach for the hydraulic analysis must be modified with the case that not all runoff will given site converge to a single point with the tip of the watershed model with an account with the general loading, land covered and stream of the panels, a characteristic account. Low impact development feature of the runoff management devices for refinement analysis may be the desired variety of tools freely available for public agencies. Our National Resource Conservation Center. The National Resource Conservation Service is formerly called the Soil Conservation Service that had been developed the runoff model of the decade of the National Resource Conservation Service, the TR20 and TR55. Account for variation in land cover, the velocity of the water movement across watershed on particular interest for the determination drainage area curve, the number and the time concentration. The value of the curve number reflects the degree of the land surface condition of the generate the runoff. The value of the time of concentration indicates how quick the runoff converges, in particular downstream. The TR20 and TR55 are popular watershed models but are generally not recommended for the predicting runoff of a small storm. Federal Highway Administration. Federal Highway Administration has developed a variety of storm software packages prominently concerned with the channel of the pipe hydraulics of the program, and most useful in those areas where detailed analysis of the flow behavior based on predetermined flow rates is required. Hydrological Energy Center of the U.S. Corps Engineer. Hydrological Energy Center Engineering Center of the U.S. Army Corps Engineers actively maintains a suite with the tools to model surface watering, hydrology, and hydraulics. The EPA maintains stormwater management model that performs simulation of both water quantity and quality of the urban runoff. In late 2002, the Environmental Protection Agency extensively revised the stormwater management model to include more detailed analysis of small-scale stormwater management device. Stormwater water management model algorithm is able to explicitly simulate storage, therefore particularly appropriate with simulating discrete low-impact development systems. Obtaining a reasonable estimate of the storage parameters of the stormwater management model is of critical importance. Creative adaptation stormwater management model is maybe necessary because the model does not directly model runoff of the impervious source of the other pervious one. Alright, Prince George's County, Maryland. Prince George's County Department of Environmental Research with the Program Planning Division working with the Tetra Tech and incorporated the development of the best management practice evaluation models, specifically assessing the effectiveness of low-impact development technology. This model uses a simplified process based on the algorithm to stimulate the best management practice with control of the model flow, water quantity, of the time series generated through runoff models, such as the Hydrological Simulation Program or Fortran HSPF. These simple algorithms include where RF control structures, storm, soil character for the flow, pollutant, transport, flow rating, network, infiltration, saturation, evapotranspiration, general loss decay, representation for pollutants, and other offers you the flexibility, design, retention, saw open channel, best management practice, define flow road over the best management practice or best management practice network, stimulate the integrated management practice such as reduce the discontinue impervious sources. Surface through the flow network of the containing the best management practice control against defined benchmarks, simulate the pre-development condition. Because underwriting algorithm based on the physical property of the best management practice with effectiveness can be evaluated, estimated with over a wide range of storm condition. Best management practice with design flow route configuration such as tool man provides a quantitative medium or assessing design of the TMDL allocation scenarios, evaluating effectiveness of proposed management probe. 5 basic design aspects of which develop the methodology of the module. They are 1. Incorporating input runoff the data. 2. Designing representation site plan. 3. Configuring best management practice various size and function. 4. Schematic representation flowing routing through network best management practice. 5. Evaluation impact site design of best management practice. The module interface is platform interactive linkage between each of the 5 design features of the module. 3516 commercial source of the edition freely available the models. There are a variety of commercial source of the market information about these other tools can be found on the internet. Model strategy, monitoring strategy, a variety of techniques are available to monitor effectiveness of low impact development features, managing water quality and quantity. Water quantity monitoring the effect of the low impact development control runoff volume peak and flow rates can be monitored either by the individual features on the site or some selected point downstream where the flow path converge a measurement device can be installed. Small scale and small scale, both manual and automatic sampling methods can be used to calculate flow rates upstream, downstream of low impact development based on the depth of measured using aware rate of flow measured using the conveyancy of the device. Large scale and large scale low impact development feature for the retrofit developed area of the effectiveness of retrofit access for the comparing the pre and low impact development and post low impact development flow rates downstream. Using the data, some of the straightforward hydrological function character of the hydrograph that can be developed to evaluate the site response to storm events resulting in implementation. Low impact development treatment of the data with the stream gauge of the indicate the runoff of the smaller storm has decreased after low impact development. As the more low impact development features with the stormwater retrofits on a site with a decreased runoff will be more significant. Water quality monitoring parameters effectiveness of the runoff management feature of the evaluated use of flow through the feature of the quality of the receiving waters or both the nationwide urban runoff program has identified the following standard pollutants characterizing urban runoff Alright, pollutant suspended solid concentration, biochemical oxygen demand, chemical oxygen, copper, zinc, total phosphate, pseudo-soluble phosphorus, total Kingaline, nitrate. Alright, biological monitoring. Pollutants of stormwater running off the direct effect of the biological integrative, the receipt of the water, effective of the water, quality control, therefore evaluated assessing biological health of the receiving the waters and vicinity. Stormwater alpha EPA has developed a rapid bioassessment protocol that can be used to characterize the existing severity of the impairments of the stream to help identify sources of cause of the impairment. Monitoring program, therefore, phase the developed monitoring program, determine the objective and scope of the monitoring program, develop monitoring plan, to view the objective, implement the monitoring program, evaluate and report the results. Monitoring programs are shaped and site character for the goals of the project with the regulatory requirements available to funds. Variability, high variability, storm flow with the pollutant concentration any location makes it difficult to obtain on the useful monitoring result of typical facilities. Must collect a large number of samples with adequate character if they have how a device function under normal condition monitoring approach to the only with a given site with a dependent regulatory requirement, pollutant concern with the physical character of the runoff management site, features, availability of the funds, personal planning, sampling analysis site, and local program performance. Water quality monitoring program should be undertaken to perform a state local protocol with a detailed guide with the manual water quality data collection, management, interpretation is available to the Environmental Protection Agency with the Department of Transportation. The guidelines of the primarily concerned with the meet with the national stormwater best management practices. Data requirements can easily adapt with a variety of monitoring activities, sample locations. Effective monitoring effort, decentralized runoff management requires judicious selection, sample location, sample time, and techniques. Changes often complete with the monitoring effectively under budget constraints. The site of the design includes many low-impact development features. Sampling only few may provide a reasonable price for the estimated effectiveness of the full suite features. Hard sample protocol monitoring program depending on the expected chemical composition, runoff pollutant, concern with the desirability of monitoring effective with the device, given active location and importance to assessing water quality. Point downstream sampling data is collected over time, trend of the water quality become the parent, and sampling data is collected over time, trend of the water quality become the parent with adjustment of the monitoring plan may be the appropriate to ensure that the across the site plan and ensure are not taken any more or less frequently than necessary to ensure the desirable level of water quality is maintained. Alright, 4. Comparison of conventional practices. Introduction. Conventional stormwater management practice focus on providing efficient transit of the rapidly conveys the runoff of the building of the pavement of the actuate of the peak of the runoff rate of the large stormwater management facility downstream. In contrast, low-impact development provides runoff management of the far upstream and is possible where it originates if necessary. Also, multiple points along each flow path. Low-impact development conventional practice that can be further compared in a variety of ways. Compliance versus water resource. The objective of the conventional stormwater management primarily concerns with the actuation peak runoff for runaway development site with the principle of low impact development ensure the maximum protection, ecological integrity, receiving the waters, maintaining watershed hydrological regime. Water control quality, conventional change of the practice effectively reduce the peak runoff rate if they do not reduce the runoff volume. Scheduled conventional drain with the practice of the increase of the runoff volume and not mitigate the effects of the increase of the impervious area. Low impact development features facilitate infiltrate with the comparison and help to reduce runoff volume directly. Runoff volume reduction using the low impact development features can be significant when infiltration increases over the significant large area. Conventional drainage reduce the amount of subsurface water available to base flow with nearby with the streams. Low impact development features enhanced infiltration can have beneficial effects on helping to maintain those base flows. Other low impact development features also tragic for the stormwater on-site with the conventional drainage design focus of moving the water rapidly off-site. Conventional stormwater management facility have been limited ability to manage water quality because of the limited removal of settlement pollutants. Low impact development approach by comparison taking advantage of the variety of mechanisms that filter the water either overland or via the infiltration on subsurface. Construction costs of the low impact development would vary depending on the character of the pre-development site, character features, the density of the development, in particular low impact development features selected, size and design. For example, the cost of the bioretention area of the functional depth of the porous backfill to the degree which under drains are utilized. Case study of the commercial townhouse, D8 active housing designs, residential areas, Prince Georgia County, Maryland, have demonstrated the low impact development site design. Cost comparable to variable favorably. Conventional approach with the costs are not simple to generalize. Scale project availability with the material scale of the training over the staff. All factors integrated management practices involved with the landscape area that often simply maintained because of the work that may offer the perform landscape crew and the residents hard. Structures such as the permeable paving systems under drains may require more specialized maintenance. Operation and maintenance, regular inspection, eventual stormwater management are required to ensure the storm volume, water volume, storage volume has not reduced the sediment outlets, not clogged debris or structural features, maintain the integrity. For site design, low impact development approach to the runoff management features will be to be a higher number than several type of the features by retention area. The need to maintain the property owner maintenance of these low impact development features, straightforward and easily performed as part of the regular landscape. Other low impact development typically employed along public streets, such as tree filters, require more specialized maintenance. Sure, filter media of the non-clog with the toxic materials such as the heavy metals do not accumulate with level to a level to which they may become a hazard. Retrofit potential. Retrofitting is eventual to develop with conventional stormwater management required with a considerable amount of space, likely to involve extensive site disturbance. Low impact development micro-scale system listed in previous chapter required the site disturbance. Each installment of the low impact development may be much easier with the conventional retrofit site, where intensive the development has already occurred. Locating site installation, small devices for easier and finding large site. Stormwater management, low impact development retrofits can be customized in pollutant loads, allowing more complete control over pollutant material. Alright, 5. Distributed microscale systems. Introduction. Additional land strategy, low impact development practice include incorporating small landscape features for the manufactured devices into the site. Management runoff of the generator, reduce the need of the management further downstream. Small distribution sites can perform several important runoff management functions. Increase the rate of infiltration, slow down runoff with reducing flow rates for the site with increasing time and infiltration, adding retention. Amount of water storage with the duration of the storm event. In addition, add detention which cover the water with the restraint temporarily before it moves the further downstream. Improve the water quality, filtering pollutant through media. Representative of the local low impact development, even the design, integrated management practice that can be selected with the customized, specifically stormwater management objective. The selective of the use of the customization of the components will involve a variety of the standard specification construction maintenance. Described below with the collection of low impact development practice of the design, construction, maintenance character of the distributed microscale system, include but not limited to soil amendment, the divider retention, dry wells, filter strips, vegetated berths, grass swells, infiltration trenches, inlet pollution, removal devices, rain barrels, cisterns, tree box filters, vegetated roof, permanent pavers. Table 5.1 variety of runoff management function provided with these features. Feature slow runoff, infiltration, retention, prevention, water quality control. Then it goes over the function of low features. Nutrient process for the water of the runoff of the urban areas can include significant quantities of chemical nutrients, particularly nitrogen, phosphorus, for the nutrients over the reach local water bodies contributed with the heterofortification, natural occurring process which nutrients accumulate in a body of water over time. The term is often used as a significant acceleration process by human activity. Several low-impact development components described in the USCT Chapter 8 filter of the nutrients various degree of the effectiveness design depending on the design. Low-impact development approach utilize vegetation not only filter nitrogen and phosphorus out of the water into the soil, but also make nutrients available to plants to form plant tissue. Treatment train approach of the water quality following the typical flow path at the beginning with runoff generated with impervious area of the runoff water quality control can be implemented in the following steps. Minimization design site with the treat pollutants effectively small quantities rather than larger quantities to run off the accumulate before treatment. Natural filterization. Use physical, chemical, biological product with vegetation soil with the filter pollutants constructed. Filterization use physical, chemical, biological products distributed microscale filterization filter pollutants. Evaporation. Storm evaporated water shallow dispersion. The depression so that the particulars can be removed. Pollution prevention, incorporate managed practice for the study of the restricted filterization, diligent street sweeping, reducing pollutant loads. Note, while the first 4 steps are above pertinent site feature, the final step pertains to the post-construction maintenance. Table 5 show the typical treatment process for the phosphorus removal. 100% load minimum and previous source of infiltration, retention, filterization, use, best managed practice, evaporation, pollution prevention. 4% of the load remains. Land use for suburban, urban, pollution load, and pound capacity, acre year. Our energy processing low impact development features incorporating the vegetation can help with the moderate high ambient air temperature. The envelope from small vegetation will have a low cooling effect. Vegetation can be selected in places of impact. Improved shading that provides buffer against wind. Use of the vegetated roots can result in significant energy with increasing saving the operation of building air conditioning. Multifunctional infrastructure buildings. Some of the low-impact development features and simultaneously provide a variety of hydrological functions, bioretention area, and an example of filtering rail runoff, filter runoff, quality control, detrain, and infiltrate stormwater into the ground. Similar vegetated root on buildings, reduce root runoff, and reduce pollutants into the both water, air, and moderate for the internal building temperature. Alright, ancillary benefit. The discussion this discussion describes low impact development primary term of the hydraulic function, low impact development runoff management strategy contributed aesthetically, planting landscape, increase the value of the property where the strategies are employed, the variety of complex projects, micro scale runoff management features, provided architectural entry for the various forms of employing berms and otherwise open space rainwater channels along pedestrian streets, foundations, intermittent stormwater bioretention area with effective subdivided large parking lots. Visible other features also provide opportunities for the citizens, property owners to become more aware of the importance of the stormwater in the urban environment. Alright, and that was the introduction to low impact development, testing.